Okay, let's go ahead and get started again. And so in this case, I'm going to give you the graph, and I'm going to have you find the center radius form of this circle. So the first thing we need to find is the center. So that's going to be right in the middle, and that's going to be our ordered pair. So let's look at this, try to find our center. Okay, it looks like it's about 3 units back, about 2 units up. So your center then would be approximately -3, +2, right, as an ordered pair. Is everyone okay with that? It's pretty simple there. Just find out your center, and then we figure out how far it is from the center to our outer edge. So it looks like if I'm at the center, then it looks like it's about 3 units here to the edge, right? So it's about 3 units. So my radius then would be 3. So my center is going to be at -3, 2. And my radius here would be at 3. Now we do want this in center radius form. So we have our center and we have our radius. So let's go ahead and write this in center radius form. Now for center radius form, remember we have to change our signs. And we square. So for center radius form, we take our center, which is -3, 2, and we switch that around. So that's going to be x plus 3, y minus 2, and my radius is 3, so we need to square the 3. So then in center radius form, we've got x plus 3, quantity squared. We've got y minus 2, quantity squared, and that's going to equal 9 from the 3 squared. And that's your answer now in center radius form. Now we're going to look at 2 equations, and we're going to talk about why these are not circles. So everything we've done so far has been a circle, but there are 2 cases where it's not a circle. And this is one of them. Now, this one I think makes the most sense as to why this is not a circle. Now, if I tried to get the circle, we would say that our center would be when we switch our signs. Always switch the signs for the center. Your center would be -5, +3. But the radius is 0. And if the radius is 0, this is a point. So this is not a circle. It is the point -5, 3. Right? So it's no longer a circle, it's a point. And why is it a point? Because your radius is 0. Okay? It has no radius, and so your point is just the center. Now, another one that's not a point is when you have a negative on the right-hand side. And we can approach this one the same way. So your center in this case would be, switching our signs, -3, and we have no y number, so we use a 0. But here's the problem with your radius. When we try to take the square root of a -16, remember what happens when you take the square root of a negative number? It comes out as imaginary, doesn't it? Right? And can a circle have an imaginary radius? No. So this is imaginary. So that means that this is not a circle. The graph is non-existent. So that graph is going to be non-existent because it has an imaginary radius. And we can't graph an imaginary radius, because we only are graphing in the real plane. So those are the two ways that it cannot be a circle. It can be equal to 0, which that would make it a point. It can have a negative on the right-hand side, and that would then make it imaginary. And that would also be not a circle, that would be non-existent. Now we're going to learn how to get these in center radius form. And I'm going to pick them from our textbook so that the numbers are a little bit nicer to work with. So I'm just going to grab a few of these from our textbook. We'll do probably 3 of them. And we'll start on page 219. We'll start with, how about question 28? And what we want to do is we want to find the center and the radius. So we want to find the center radius. And we get that by finding it in the center radius form. And so on 28, we've got x squared plus y squared. We've got a plus 8x minus 6y plus 16 equals 0. So what we first want to do is when we look at this, we want to get it eventually in center radius form. So the first thing we do is we make sure that we isolate all the x's and the y's on the left. So that means we move that 16 over. So we want to isolate all x's and y's on the left. So we're going to move that 16 over so that it's on the right. So all the x's and the y's are on the left-hand side. And everything that does not have an x or y is on the right-hand side. So that's our first step. So always make sure that the x's and the y's are located by themselves on the left. All the numbers go to the right. And now we're going to have to complete the square. And what we do is we half and square. So we're going to do this for the x part and the y part. Okay, so we need to make sure that it eventually looks something like that in a way. Okay, so that's what we want. Something like that. I'll have a number on the end, but we want it to be in this general form. We want it to be in center radius form. So we are going to go back and we're going to look at our circle equation here. And we move that 16 over. Okay, and now we're going to have to work with it. It's just really crooked today. And we're going to have to work with it. We're going to work at the x part by itself. And then we'll look at the y part. And we're going to have to complete the square. Now what we have to do is we have to add something to make it factor. And we want it to be a perfect square. So what we do is we half and square. So when we bring this down, we half. Okay, so we half the middle. And what's half of 8? Half of 8 is going to be 4. So that comes down as an, and bring your sign down, x plus 4. And 4 squared is 16. And we've got to keep track of that 16. Because whatever we do to one side to make it factor, we have to add it back to the other at the end. So we've got to make sure we keep track of that. But it's really not difficult. Half and square, that's all you have to remember. It's half and square. What about the y part? It is y squared minus 6y. Well, we half. All right, so what's half of 6? 3. So that comes down as a y minus 3. Now we have to add something in to force it to factor. And minus 3 squared is a 9. So the 9 gets added back in. Is everyone okay with that so far? And we're going to do 3 of these to make sure we see how they're done. It's always, though, half and square. Half and square. It's all you have to remember. Now we rewrite it. So now we rewrite it as x plus 4, quantity squared, y minus 3, quantity squared, and then what was it equal to before? Well, if we remember up before, it equaled that minus 16 up here. So we've got a minus 16. Now, what are we adding in? What's in our black boxes? 16 and 9. So add in a 16 and add in a 9. Those could cancel. And so what's left over is x plus 4, quantity squared, y minus 3, quantity squared, equals 9. And so can someone tell me what my center would be? What would my center here be? Yep, negative 4, positive 3. And what's my radius? Yep, it's not 9. No, it's a square root of 9, which is then, yep, you're on the right track, though, 3. So there's my center. And there's my radius. So center is an ordered pair, minus 4, 3. And the radius is simply 3. So let's look at one more of these. How about question 30? We'll do question 30 next. And then we'll look at one where you have to divide out. So let's do question 30, which is x squared plus y squared minus 12x plus 10y equals a negative 25. Okay, so move this up so we can see it here. So there is our equation. And again, we want to find the center and the radius. Well, there's actually less work on this one because we already have the x's and the y's located on the left-hand side, and that 25 has already been moved over. So that part is done. Now we need to work with the x part and the y part separate. And what's our scheme? We're going to half and square. So what do we do here? We've got a minus 12. So what do? We take it and we half it. So what's half of this negative 12? Half of negative 12 is a negative 6, right? You keep the sign. And then when you square that negative 6, it becomes a positive 36. So that's going to go in the box. Because that is 6 squared, which is then 36. Now we repeat the process with the y part. And for the y part, we have y squared plus 10y. So can someone tell me what comes down? Okay, y plus 5. And then what's going to go in the box over here? Yep, 25, because that's 5 squared, that's 25. Now, rewrite it, and we're almost done. So rewriting, we get x minus 6 quantity squared, y plus 5 quantity squared, and that equals a minus 25, which is already there. Then we add on a 36 to force the x part to factor. We add on a 25 to force the y part to factor. Those 25s can cancel, right? And that leaves you now with x minus 6 quantity squared, y plus 5 quantity squared. And that equals your 36. And so your center would be, what, can someone tell me what that center would be? Yep, it'll be a positive 6 and a negative 5, right? Because that's your center. You switch your signs. And your radius would be not 36, it is square root of 36, which is then a 6. In some cases, you may have to divide it out. If you have a number that is in front of the x squared and the y squared, and it'll be the same number, in that case, you're going to have to divide it out. So let's look at, how about question 32? This one's going to make us divide it out. So it has one extra step. Sure, that's a positive 12x there, negative 18y, and a minus 23 equals 0. So, again, first thing we need to do is whenever we approach this type of problem, we need to go ahead and move that 23 over because it doesn't have an x or y, so it needs to go to the other side. And now we've got 9x squared. 9y squared plus 12x minus 18y equals 23. Now we have no choice. We have the 9x squared and the 9y squared. We do not want 9s or any other number in front. So in this case, we need to make sure that it is an x squared and a y squared. We have to divide by 9, even though that might make fractions. We have to divide by 9. So we're going to have to divide everything by 9 because it has to be x squared and y squared. No number in front. They're always going to be the same number. If they were different numbers in front, like one's an 8 and one's a 7, that would be an ellipse. And we don't cover ellipses in this course. That's a calculus type of problem. So we're only working with circles. And so we divide by 9. Now, like in your homework, okay, if we look at question 4 from your homework, see, this one we'd have to divide everything by a what? 2. And that was actually a little bit easier in your homework because it comes out to be whole numbers. This one actually gives us a couple of fractions. And that's okay because we can still work with them pretty easily. So now let's see what we've got. When we rewrite, we've got x squared plus y squared. That's what we wanted. And we want to reduce it down as much as we can. 12 over 9. Well, 12 over 9 would reduce down to 4/3 x. 18 divided by 9, it's negative, so that makes it a negative 2y. And we're going to leave that 23 over 9 as a fraction. Now we complete the square. So now we look at the x part. Okay, well, how do we half a fraction? We half a fraction by multiplying by half. So we're going to half this fraction. So we take our 4/3 and we multiply it by a half. Because that's how you half a fraction. You just multiply it by a half. And you can either cross cancel or you can just reduce it down at the end. It doesn't matter. If I multiply across, I get 4/6, which is then 2/3. So you half a fraction by simply multiplying it by a half. Now, how do you square a fraction? Multiply it by itself, right? So how do you square this fraction? Well, you take that 2/3 and you multiply it by itself. Multiplying out, that gives you 4/9. So that's what you got to add in to force it to factor, 4/9. Easy enough there. Like I say, it looks a little bit more intimidating with the fractions, but it's really not. And they're all going to go away at the end. So we don't have to really worry about them because they're all going to cancel out. What about the y part now? The y part is quite a bit easier. For the y part, we have y squared minus 2y. So that minus 2, we half it. What's half of minus 2? Minus 1. Okay. And then minus 1, when we square it, becomes a positive 1. So we're going to have to add in a 1. Now, rewrite it and see what we've got. I'll bring the original back up so we can kind of see. If I rewrite it, I've got x plus 2/3, quantity squared, plus y minus 1, quantity squared. That equals 23/9. And we're going to add in 4/9, and then we're going to add in 1. And if you need to, just do the 23/9 over to the side. Okay, 23/9 plus 4/9, well, that's a 27/9, and that comes out to be 3. So see, we're in luck there. So this piece comes out to be a 3. And then that 3 plus the 1 makes it a 4. Now we've got it in center radius form. And we can now find our center and we can find our radius. And what would our center be? Switching the signs. Center would be minus 2/3, comma positive 1. And your radius, the square root of 4, which is then a 2. And that's it for 2-2. This chapter, I believe, is going to be a lot easier for you than Chapter 1. Chapter 1 is the hardest chapter because it's reviewing and it's building up a lot of things that are difficult, take time to go through, applications. The later chapters, I think, are much easier. So graphing, I think, is much easier than solving some of those tricky equations from Chapter 1. 2, 3 is functions. So 2, 3 is going to be functions. And there's very, very little to 2, 3 to really look at. And we've talked about this before in previous courses. So let's talk about how we decide if something's a function or not. How we decide if something's a function or not is if we have a graph, we have what's called the vertical line test. And what we do is we draw vertical lines. And if any line touches the graph, at more than one place, it is not a function. Okay, so you draw vertical lines, and if any line touches that graph at more than one place, it's not a function. Now, we will later on learn about the horizontal line test, and that's completely different. That talks about inverses, but that's a later chapter. So all we're going to look at today is the vertical line test. So you draw vertical lines, and if any line touches the graph at more than one place, it's not a function. Now we can also talk about the domain and the range. The domain is the values of x, the possible values of x. And the range, sometimes called the target, is the values of y. So the range is the values of y. Domain is going to be our values of x. And I know we've covered these before, and there's not much to these. I'm going to give you some graphs, and then we're going to talk about these graphs, and we're going to find the domain and the range. And tell me if it's a function or not. So here's a graph. So here's a graph, and I want you to tell me if it's a function, first off, and then also find the domain and the range. So is this a function? Now remember, how do we tell if something's a function? Okay, we draw vertical lines. And so if any line touches the graph at more than one place, it's not a function. Well, if I draw my lines, they only go through this black graph at one spot. So in this case, it passes the vertical line test. So this is a function. Now we look at the domain. And when we look at the domain, we look at the values of x that it can be. And when we look at this graph, we notice that this graph is going back to the left and to the right. So it goes to the left and it goes to the right. So my domain would be negative to positive infinity, because it goes to the left and it goes to the right. Now what about the range, the up and down part? Does it ever go up above this 5? No, right? It never goes up here. It's always down below. So what's my range going to be? Well, my range is going to be 5. And where does it go to? Negative infinity. And we use a bracket at that 5. And so it goes from 5 down to negative infinity. And in this case, it is a function. do another one. Is this one a function? Yes or no? Yeah, it is a function, isn't it? Right? Because every line touches at only one spot. So it is a function. Now, what about my domain? Okay, the domain is the values of x. And we look at where it starts at on the x-axis. So it starts here at 4, at that negative 4 right here on the x-axis. Remember, the domain is the x-axis. So it starts at 4, and which way is it going? Is it going to the left at all? No. It's only going to the right, and when it goes to the right, remember, that goes to positive infinity. So my domain would be 4 to positive infinity, because it's going to the right. What about the range, the up and down part? Okay. Yep, and when we look at, do what now? Yeah, when we look at our range, we look at where it starts at on the up and down part. So on the up and down part, it starts at 2, doesn't it? And what is it doing? Is it going up or down? Down. So my range would then be 2. And where does it go to? Negative infinity going down. So your range would be 2 to negative infinity.
On the domain, I think she was asking if that's a negative 4.
My mistake there. Yes, it should be a negative 4. Sorry about that.
Like,
yep. Yeah, that was my mistake. Yep, should be a negative 4 there. But does it make sense how that works?
Yeah.
And a lot of this, I think, should be something you've seen before. Now let's look at something that's not a function. And we looked at a lot of these today. Circles. Circles are not functions. That's going to be 0 or 5, 0 here. And I'll just kind of draw it here. So why is this one not a function? Well, this circle is not a function because if I draw a vertical line, okay, that vertical line touches that circle at 2 spots. So this is not a function. Now we look at the domain. And the domain is going to be our values of x. Not the y, the x part. So the domain is going to go from 0, okay, and there's our center at 5, 0. So my radius is about 5 here. So it starts at 0, and it goes over here to about 10. So my domain should be 0, 10, right, on the x-axis. What about the range, the y part, the up and down component? Well, the up and down component in the middle here is 0, so it's got to go up 5, and it also has to do what? Down about 5. So my range would be -5 to 5. Is everyone okay with that? So between there, that's all you have to do. Now, what about for equations? How do you determine if an equation is a function? Well, an equation is a function if you can solve it for y. So an equation is a function if we can just simply solve it for y. So I'm going to give you 4 of these, and you're going to tell me if this is an equation, or sorry, if this is a function or not a function. And we don't even have to really solve these. All we have to do is look at them. So we're going to see if these are functions or not. So let's look at our first one. Y equals 8x minus 7. Very simple. I'm not having you find the domain and ranges on these. All I want you to do is tell me if it's a function or not. Okay? Has it been or can it be solved for y? Yes, it has been solved for y, hasn't it? Right? So the first one is a function. So yes, it has been. What about the second one? Is it a function? Yes or no? Yeah. Why is it a function? Because I can solve it for y, can't I? And if you can solve it for y, that makes it a function. So that one was able to be solved for y because we've got y equals minus 1/3 x plus 2/3. So that is also a function. What about the next one? Is it a function? Does anyone want to take a guess on this one? Is this one a function or not? Yep. Very easy on that one. It is. Now, what about the last one? Is it a function? No. Why not? Can't solve it for y because it's y to the fourth. Right? It has to be y, not y squared, not y to the fourth, not y to the sixth. So this one is not a function. We've got two more really short topics to cover in 2-3, and then we'll probably be able to go on to 2-4. And 2-4 is nothing but slope. So we may actually be able to get through 2-4 today as well. There's, like I say, these sections, not much to them. I didn't give you that many questions on them either. So we're now going to look at these functions, and we're going to look at equations. And what we're going to be doing here is we're going to be solving for y. And replace y with the function notation f of x. So we want to rewrite these in function notation. And sometimes function notation might be easier to work with than having a y value. So we're just going to rewrite these. So we're going to solve it for y. Then we're going to replace it with our function notation f of x. And so all we need to do is solve it for y. And then we replace that y with f of x. So nothing new here. We move that 8x over. So minus 3y equals a minus 8x plus 2. We divide by our negative 3. And so now we have solved it for y. And what's our last step going to be? The only new step is we replace that y with what? We replace y with f of x because we want it to be a function. So now our final answer would be f of x equals 8/3 x minus 2/3. And that's it. That's all you need to do. Solve it for y and replace y with f of x. And I don't think we need to do another one of these because that's pretty much straightforward. And that goes with questions 2 and 9. And they're pretty much the same. Solve it for y, replace y with f of x. So this is going to be like homework 2.3, questions 2 and 9. The last part of this section is talking about increasing, decreasing, and constant intervals on these functions. Now, when we talk about these, we're going to be labeling them on the x-axis, not the y-axis, and that's where students sometimes get confused. So we're going to be labeling on the x-axis, and when we talk about increase, that means we go up from left to right. Decrease, we go down from left to right. Constant means we don't change at all. Means it doesn't go up or down. So we'll say no up or down movement. And we need to make sure we label on the x-axis. Not the y. And so we'll do 2 of these. And they're just looking at pictures. There's 2 of them in your homework. So we're going to do 2 of these. And we're going to have to label where it increases, where it decreases or stays constant. Okay, so here's your picture. I'm going to have you label this from where this increases, decreases, or stays constant. So what we're going to do is we're going to label the graph first. So we look at it from left to right, and we start at the upper or lower left corner, wherever the graph is, and we follow it. Now, if we follow this graph and we look from left to right, this is going up, right? This is constant here, and then this part is going what? Back up again, isn't it? So first off, when we look at this graph, does this graph decrease or go down at all? No. Okay, so it never decreases. So there's no decrease there. Now we have to label on the x-axis, not the y-axis. And let's do where it's constant. Where is it constant from? On the x-axis. It's constant in this interval here, isn't it? Right? And on the x-axis, what would that be? -4 to 6. So it's going to be constant from -4 to +6. Where does it increase from? When we've got 2 parts here. So we'll start with the left-hand side. Now, this graph is going down, so it goes actually way down here, right? Okay, so it actually increases from negative infinity, as we're doing the x-axis, and it's increasing all the way up from negative infinity, which is over here, and it stops at where? Negative 4. Then it goes constant, which is there, and then it starts increasing again at what? 6. And it goes on to positive infinity. Now we're labeling on the x-axis, not the y-axis. That's where students make a mistake with these, is they think about it in the wrong axis. Let's do one more. So let's do one more. I'm not even going to label the y-axis because the y-axis is not what we're looking at. You have to label on the x. So do not label it on the y-axis, only label it on the x-axis. So don't even worry about the y-axis at all. When we look at this, what's it doing? We start here, and we go up, and then we do what? Go down, don't we? So where is it increasing from? This region, right? So where does it increase from? Negative infinity. And where does it stop increasing at? 7. Where does it decrease from? 7. And then, now, where is it going? It's going down and it's going to the right. And so it's going to positive infinity. So it decreases from 7 to positive infinity. We don't worry about the way that it's going here. We just look at the fact that it's on the x-axis, not the y-axis. And as we go to the right, that goes to positive infinity. Do we have any constant part at all? Is it ever constant? No. So believe it or not, that finishes up 2-3. There's very little to these sections, and they will not take long to go through. So now we should be able to also get through 2-4. And again, you'll see there's not many questions on these homeworks. They're going to be a lot faster for you to go through than what we did in Chapter 1. 2-4, I think we're going to be able to get through today because there's really not that much to it. 2-4 is the beginnings of line equations and slopes. And our slope is going to be defined as rise over run. And we're first going to learn how to graph a line with just a point and a slope. There are 3 ways that we can graph a line. We've already covered one of them. One way is by plotting points. If you've got 2 points, you can connect them together and make a line. That's one way. You can also graph a line when you have a point and a slope. And you can also graph a line from an equation, which we'll look at later on today. But I'm going to right now give you a point and a slope, and I want you to graph this line. So you're going to have a point and a slope. We're going to use this to graph the line. So we're going to graph this, and let's say you're given the point 4, 3, and a slope of minus 3/2. How do we graph this line? Well, we need to come up with 2 points. The first point is already there, so let's begin by simply plotting our point. So we're going to plot our point, and that's going to be at 4, 3. So that's over 4 and up 3. Now, when we look at our slope is minus 3/2. So that means we go down 3 units and we go over 2 units. So from that point, 4, 3, we're going to have to go down 3 units. So that makes it right to here. And then over 2 units. And let's go ahead and label that second point. So I'm going to have to go down 3. So it was at 3, so that makes that then 0 for the y part. And then we were at 4. We have to go forward 2 units, so 4 plus 2 makes it then a 6. So that's my second point at 6, 0. And now we've got everything that we need to graph this line. Because all you have to do is plot your point. Move it with the slope, and you're done. So one more of these. Well, let's not make it 3. Let's make it a different number so we don't get confused. Let's make that a negative 4. So that's going to be a 4 there, negative 4. So what do? If we want to graph this, we plot our point. So that is at 0, negative 3. So a lot of times students mix them up. 0, negative 3 would be at 0, and then down 1, 2, 3 units. And there's our first point, 0, negative 3. Now, what about my slope? We're going to look at negative 4 over 1. So that means we go down 4 and we go over 1 unit. Now, I always like to label the point. You don't necessarily have to, but I like to label it. So let's see what happened. Okay, I was at 0 on the x-axis. And how far am I sliding forward? I'm sliding forward 1 unit. So that becomes a 1, right? We went over 1 unit. And then what about the down part? It's down negative 4. Now I'm at negative 3. Yep. And add 4 to that, subtract 4 from that, that makes it a negative 7. So my second point is at 1, negative 7. I've got my 2 points, so I can go ahead and graph them together. Now let's talk about how to graph a line from an equation. And we're going to be graphing a line from an equation, and I know you've done this many, many times. We have what's called the slope-intercept form. And the slope-intercept form is y equals mx plus b. And the m, that represents the slope. And the b, that represents your y-intercept. And that's 0, comma, b. And I know we have done this numerous times. All we need to do is solve our equation for y. We find our slope, we find our y-intercept as an ordered pair, and we graph it. And we're also going to put the domain and range down. So we're also going to graph it and find the domain and range. Now this one happens to be in function notation, which is okay, because in function notation, we should remember that f of x is nothing but a y, right? Because f of x and y can be used interchangeably here. And so we have it basically in slope-intercept form. So the -7, that's going to be your y-intercept. And this 4, well, that represents your slope. So now we're just going to go ahead and graph this quickly here. And we've got everything that we need because we have a slope and we have a point. And we did these a moment ago. So we find our point, our y-intercept. So that's down 7 units. So there it is at 0, comma, -7. Now what about my slope? Well, my slope is a 4 over 1. So that means we're going to have to go up 4 and over 1 unit. So we're going to go up 4 and over 1. There's my second point. Now, you don't have to label them. I always like to, though. So we went over 1 unit. We're at 0. So we went over 1, so that makes it a 1. And then we're at -7. We're going to add 4 to that. And -7 plus 4 makes it a -3. So there's my second point at 1, comma, -3. And now we've got it. And we can connect them together. And there's our graph. Now, what about our domain and range? The good thing about all of these graphs is they're all going to have, unless they're a constant function, they're all going to have the same domain and range. Look at this graph on the x-axis. What's it doing? It's going up from left to right. So it covers the entire x-axis. So my domain would be negative to positive infinity. And what about the range? It goes up or it goes down. So it would also be negative to positive infinity, right? So domain and range are the same. And they're all going to be this way unless it's a constant function. And we'll talk about a constant function here in a moment. So let's do a couple more of these. Then we'll talk about how to find your slope when you're given 2 ordered pairs. So if I gave you this one and I wanted you to graph it, Well, the first thing I need to do is I need to go ahead and solve this for y. So I'm going to move that 4x over. And then I'm going to divide by my 3. And I'm going to reduce it down as much as I can. So then that reduces down to now be y equals minus 4/3 x. And 6 over 3, well, that's a 2. And now we have everything that we need to graph this line. We have our y-intercept, which is our point. And our y-intercept is 0, 2. And what about our slope? What is our slope? Right there. And that's minus 4/3. So we're okay with that so far. Okay, now what do? We plot our point. Zero, 2, so that's up 2 units. So that is right there at 0, 2. What is our slope? Minus 4/3. So we're going to have to go down 4, and we're going to have to go over 3. So let's find our ordered pair. I'm at 0. How many units am I going to go forward? You always go forward, never backwards. I'm at 0. I have to go 3 units forward, so that means my x component is going to be 3, right? Because I'm going to 3 units to the right, so slid 3 units over. Now, what about the y component? I'm at 2. What am I doing? Taking away 4, so 2 minus 4 makes it a minus 2. So there's my second point, 3, negative 2. That's all we need, because now we can simply connect them together. There's our line, and what's my domain and range? They're always going to be the same unless it's a constant function. And my domain is negative to positive infinity, and my range is the same. So let's do another one. We'll do one more of these, and then we're going to talk about what makes something a constant function. Because that's the only part that we haven't covered yet, besides finding the slope. So let's do one more of these. So let's go ahead and try to graph this one. And so if I want to graph this, remember I need to solve it for y. So I'm going to subtract off the x here. And that's minus 6y equals now minus x. We'll divide by our 6. Negative and negative makes it a positive. So that's y equals 1/6 x. And I did pick this one on purpose because this one has no number on the end. So that means my y-intercept is 0, 0. Right? because there's no number here, so that's actually like having a plus 0. It's not there, but when we write our y-intercept, that's 0. So that's going to be a 0, 0 for my y-intercept. And then my slope is 1/6. So when we go to graph this, it's very, very easy to graph. Here we are at 0, 0. My slope is 1/6, so that means I go up up 1, and I go over 6 units. So this one's actually easy to work with. I'm at 0, 0. X goes first, so what am I doing? I'm at 0, 0. So I'm at 0 on the x-axis. I'm going to add 6, so that makes it a 6 there. What about the y-axis? I'm at 0, 0. I'm going up 1, so that makes that y component of 1. So my second point would be 6, 1. And now I've got the 2 points that I need, so I can connect them together. There's my graph. What about the domain and range? Well, they're the same, negative to positive infinity. Now let's talk about what's a constant function. So a constant function means it doesn't increase or decrease, it just goes straight across. So it never increases, never decreases, it stays the same. That's a constant function. So this is a constant function. F of x equals 5. This is a constant function because there's no x on here. It's just 5. So this is called a constant because of the 5, because there's no x on it. If it was 5x, we would graph it and would have a slope. This one is constant because that's just a 5. No x on that 5. So no x on the right-hand side. So that makes it a constant function. And how would we go to graph this constant function? It's f of x equals 5. So that means it's stuck at 5 everywhere. So f of x equals 5, and we'll do one with y in a moment, but it's the same. F of x equals 5, that means we start up 5 units. So 1, 2, 3, 4, 5 units up. It's a constant function, so it just goes straight across like that. So that's a constant function. So if there's no x on the right-hand side, that makes it a constant function. What about my domain? Okay, the domain is the values of x. So the domain can go, this function can go to the left, and it can go to the right. So my domain would be negative to positive infinity, because the domain is the values of x. And then when we talk about the range, well, the range is going to be the values of y. And there's only one value for y, and that's at 5. So this is pretty much stuck at 5. It can go left or right, but it can't go up or down. So it's stuck at 5. You can also have a constant function that's a y equals. So it can either be f of x or it can be y. And so if it's y equals, let's say, negative 3, This is a constant function, right? Because there's no x. Again. So if there's no x on the right-hand side when you solve it, that means it's a constant function. And if it's a constant function, what does your graph look like? Well, your constant function is going to be at y equals 3, negative 3. So we have to go down 3 units. And then it's simply a horizontal line just like this. Okay, it's a constant function. An x line would be up and down. And we don't even really talk about those too much because those have no slope. And they're not even functions. So this is a constant function. And what is my domain? The domain is the values of x again. And can someone tell me what the domain would be? Yep, very good one. Yep, negative to positive infinity. And what about the range? Where is it stuck at? Yep, negative 3. So that's it. Now, the very last part of this section is how we find the slope. So we're going to be finding the slopes now. And it's a formula. It's just like how we did the distance. So we do pretty much the same process as we did with the distance formula. Except we don't have to square it and we divide them. So the slope formula is m equals y1 minus y2 over x1 minus x2. And I know the textbook has the y2 minus y1 and the x2 minus x1. They flips them around. I like it 1 and 2. I think it's easier for students to keep track of. So I'm just going to write it as 1 and 2. We're going to do 2 of these where we just use our points, and then we're going to do one of them where we look at a graph. And we use that graph to find the slope. And this is also called average rate of change. So the slope is also called the average rate of change. Sometimes called the grade or the pitch of a road if you're working in a construction field, or pitch of a roof, grade of a road, pitch of the road. Those all mean the slope. Average rate of change, that's going to be something that you use in a business class. If you were looking at the stock market, average rate of change, that means how much did it change over time. And so we're going to be using this formula here to find the slope. And you're going to be given 2 points. So we're just simply going to use our slope formula to find our slope. And just like we did with the midpoint, and just like we did with the distance formula, we label it x1, y1, x2, y2. Be very, very careful with double negatives. I always like to write my formula out. It's y1 minus y2 over x1 minus x2. So that's 8 minus 4 over minus 3 minus 5. 8 minus 4 is a positive 4 in the numerator. Minus 3 minus 5 is a minus 8. And I reduce that down. So my slope would be a minus 1/2. And that's it. Just use your formula, work it out. Very little to do with these. One more, and then we'll look at a graph. So again, we're going to find the slope. And you're given 2 points. So let's say you're given 8, 7, and minus 3, minus 14. So again, all we need to do is we need to simply find the slope here. So x1, y1, x2, y2. If you make a mistake, it is going to be with the double negatives. So whenever you have the negatives, remember, you're subtracting it off, so sometimes that makes a double negative. I always, again, like to write up my formula because I feel like repetition is the best way to get these formulas down. So then you've got m equals y1 minus y2 over x1 minus x2. And I fill them in, so that's 7. Now watch your signs here. Minus a minus 14 over 8 minus a minus 3. So be very careful with the double negatives. That makes that positive here. And also here. 7 plus that 14, that should make it a 21. And 8 plus 3 makes it 11. So there's your slope. And your slope is 21 over 11. Now let's look at a picture. And let's try to find the slope from this picture. I'll make it pretty easy here. Okay, so let's say I give you this here. So I want you to find the slope from this picture. So here's your picture. And I want you to find this slope. Now first off, we know that my slope is going to be negative because this is decreasing from left to right. When I look at my line, it's going down. Now, in order to find this slope, well, I need to come up with 2 points, right? 2 ordered pairs somewhere. So all we have to do is look at the graph, and we find 2 points on this graph. And you can use any 2 that you want. So when I look here, it looks like when I reverse label this out, okay, this point right here, make sure you put them in the correct order. This point right here is going to be about, I know it's hard to see, but about 3 over. And about 5 up. So that's 3 comma 5. Remember, make sure the x's goes first, y is the second component. And then this other point over here, well, if I read my graph, it looks like it's about 8 units over and about 2 units up. So you look at your graph and you find 2 points by just reading them off the picture. Now, once you have them off of the picture, now you can apply your slope formula. So now we've got our 2 ordered pairs, and we're going to find the slope. And we know this should be negative because it's going down from left to right. So we're going to be using the point 3,5, and we're going to be using the point 8,2. And m equals y1 minus y2 over x1 minus x2. And we're going to go ahead and plug our values in. So that's going to be 5 minus 2 over 3 minus 8. 5 minus 2 makes it a positive 3 in the numerator. 3 minus 8 makes it a minus 5, and that's a minus 3/5. And we know that's correct. Let me move that up so we can see it here. Sorry about that. We know that this is correct because our slope should be what? Our slope should be negative, and it is. Now, we have covered a lot of material today, but I think you'll find that this homework is very easy to go through. I mean, it's going to not take you near as long as anything from Chapter 1. So your homework for next time is 2-1, you can do them all. 2-2, you can do them all. 2-3, you can do them all. And 2-4, you can do them all. So you should be able to do sections 1 through 4. Should be able to do all of those. And I will see everyone then on Wednesday. And again, it shouldn't take you long to go through these. They are not difficult. Most of them are very easy. If you've got questions, be sure and ask. The only new material is 2-2, which was circles. Everything else should mostly be a review.